what we will be talking about is just different techniques and ways to optimize the 60 frames per second section of the web optimization project. So what is this 60 frames per second? Just want to remind everyone who are on Project 4 or who will be on going on Project 4 is that you need to achieve 60 frames per second when you are scrolling. So basically, when you're browsing, when you're scrolling through the website on the pieces page, all those little pizzas that are animating in the background are should be rendered at 60 frames per second. So let's first look at the Google Dev Tools and see what does that really mean. This is Google Dev Tools here. This is what recording the timeline looks like. And if you can see here, what I basically did, I launched the Dev Tools and I picked on the line option. I then look in and record my timeline. I press this black button here, and then I scroll up and down here. And Google DevTools will give me a nice timeline that will tell, okay, how much time it takes to calculate my events using my scripting, how much time it takes to lay out my elements, and how much time does it take to paint my elements. As you can see here, these individual bars, they all should be lower than this 30 frames per second line. We do not even see the 60 frames per second because the calculations are so high that it's beyond 60 frames per second. It's actually lower than 30 frames per second. So basically what we want to do is we want to squish and lower the height of these bars so low that the 60 frames per second line will show up, and we could then be able to see, okay, whether we've achieved 60 frames per second. So we're going to walk through like different stages of an optimization, and we're going to show you how things will look like once you optimize certain things of your code. So the first thing that I want to show you, realize here is the code. Whenever we scroll, we're going to launch this function here at line 577. So window add event listener scroll. So it's going to listen to the event whenever a user scrolls. It's going to launch this function here, update positions. And this is the actual function that we need to optimize. There we go. And then we're going to scroll up and try to look at the definition of update positions. So it's right here. So basically, we know that we need to somehow optimize this this function, because guess what? From our timeline, as you can see, like if I were to click on one bar or one frame, it takes us a lot of time to actually calculate all of our calculations to be able to calculate all the pieces that's scrolling. So basically, this is how you should read this event, the scroll event, is that you have this event scroll. This takes up a lot of time, and then the next event will be a recalculate style. It goes into layout. Then it goes into paint. It's painting the actual pixels on screen. And then it does some other previous calculations that are not so trivial. But basically, the main bottleneck looks like this yellow thing, which is on event scroll. If you click and expand this, you see this function call here. And this function call is update positions. So that's update position. So I already know that I have a bottleneck. We go and step through this function. I commented this function fairly well, and I just commented with my questions and my observations. So basically, your first step is to look at each line and really understand what each line is trying to do. In this case, I am getting all the pizzas from here because all the pizzas that are animating has a class named mover. I'm going through a for loop, and then I'm doing a lot of calculations here on 531. And then I do this calculation here on line 541 to actually change the left position on each pizza. Now, the first thing that I want to ask is like, okay, focusing on this part right here, is that like, okay, in order for me to understand whether this loop is efficient or not, let's log out all these numbers and see. Let's log out. Basically, what I would do, I would like basically do a console log. I will log out the phase number, and I will log out the document by scroll, and basically any other type of variable that is being calculated. And I want to see which variables are really necessary crucial for me to leave inside my for loop and which can be outside the for loop. Because basically, I'm thinking if it's a for loop and this is the majority of the instructions here, I'm doing a lot of like calculations that per loop, and I'm trying to think, is there any way for me to reduce the amount of time to calculate these calculations? And notice that another optimization that I'm looking at is when the DOM has been loaded. This basically says if the page has been loaded, I'm going to create 200 pieces that will be animating and assign them the class mover, right? So because basically all the animated pieces are assigned to class mover. That's when we know those are the pieces that should be assigned, that should be animated. And I want to ask myself, there's 200 pieces that should be animated, but then if I go back to my pizzas page, I'm only seeing a handful of the pizzas that are animating at any time, any point in time. So my second question is, do I necessarily need to animate 200 pieces if only a handful of them are showing up on my screen? So food for thought for everyone. I'm giving everyone hints. I'm actually not going to give anyone the answers, but hopefully this will give you guys and gals good enough hints for you to start thinking about certain aspects to your function, and to try to basically pick apart every line of your code and try to ask yourself, can I make each line efficient as much as possible? Okay. Basically, if I were to make those optimizations that I talked about, I'm gonna get a timeline like this. As you can see, this timeline is drastically different. So now we can see the 60 FPS timeline, and this is the goal. Our goal is to be able to basically get all the color bars underneath this 60 frames per second line. And if I were to actually go and click on a bar here, select the bar, basically reduce my timeline, I can see that my event strobe, my yellow here, which used to take up the whole time, the whole 16.667 milliseconds, it has been drastically reduced to around 0.642 milliseconds for scripting. If you look at the numbers here to my lower right-hand corner, it went from 25 milliseconds to 0.642 milliseconds. So that's pretty good optimization. And actually, for just to meet the minimum qualifications, this is good enough. We still have a couple of other things that we could increase optimizations on, especially the paint here, because the green bars here, and a little bit of the purple bar here, because this is actually the layout. Remember the stages in rendering from the web optimization class? We have the HTML, the DOM. We then download the Seesaw. We look at the JavaScript. Then we go into the render tree. Then after that, we go into layout. We actually lay out the elements. And then we actually paint. So this actually shows you the relationship of like, okay, I have events, JavaScript. I'm going to do layout because I've rendered my render tree already. I go and paint, and then I basically rinse and repeat. If you think about it, this yellow line could actually be reduced a little bit more. We can actually have a little bit more optimizations in our JavaScript, and we can actually get rid of one of these stages called mainly the layout stage. So let's go back into the code and figure out what else can we do. So the first thing that we see that any other things that we can squeeze out, any other performance, is using query selector all. Because basically, there's a more efficient way to access your DOM. And that's using document get elements by class. This is actually a more efficient way to get all the pizza elements in Mover. So this is actually a good way to make things more efficient. Another one is this line here, this modulo operator here. If you notice, let's go back and understand what the modulo operator is. Like, the modulo operator, I'm looking at my notes, gives us the remainder when we divide I by 5. So it's a remainder. It's not a division, it's a remainder. So basically if I is one remainder of 5 is 1. 2 remainder of 5 is 2, 3 remainder of 5 is 3, and so forth. And these numbers repeat itself. So basically we will have, in a nutshell, if you do all the math, this will be just 5 numbers. No matter how many pizzas you have, whether it be a 200 pizzas or 1,000 pizzas, every time you iterate, you will only have 5 unique numbers because the modulo operator basically gives us just a remainder, and we fix the base number of 5. So we can actually, if you think about it, we can actually, why can't we just store 5 numbers and then use those numbers to change the position of our elements? One last thing here is that a lot of people have like wrote on the forums is to use some sort of CSS3 hardware acceleration here because basically CSS3 has hardware acceleration and certain transformations that reduce the need to re-trigger a relayout. Basically, what I'm talking about is a lot of people use this, translate X. And if you look it up, there's a ton of articles that talk about this sort of CSS hack to increase your speed. So again, you could do this to in order instead of like using style left, you use transform translate X to actually position your elements. Now, what this does is this gets rid of the need to trigger a relayout. And if you think about it, it just basically gets rid of one event in the purple bar. And a lot of people says you need to do this, you must do that. If you think about it, let's go back and look at the numbers. Once we do that, it doesn't really make that much of a difference. It does, but then in this case, you can get away with perfectly using this level of code. For every scroll, I'm repainting the whole screen. Now, the question is there a way for me to only paint the moving pieces and not the rest of the screen? Because everything else doesn't need to get repainted because the pixels are still good. So like, is there a way for me to reduce this green bar so I could like reduce these total bars to like basically like near 0? How are we gonna do that? It's a very hacky way. So I want to preface that this is there are trade-offs to doing this hacky way. So just be aware as a developer of the trade-offs. So there's a hacky way to reduce the paint now. Because basically what we do is that we tell the browser to actually render our pizzas, our individual pizzas, and put them into individual composite layers. Because basically, even if there is one pixel that's changed, the whole layer gets repainted. So what we do is we put all of our individual pizzas into their individual layers. Now, how can we do that? We actually do some CSS hacks. The hack that I'm going to use is called backface visibility hidden. I'm actually going to use this hack to actually force the browser to render each pizza element in its own layer. So basically, if I were to animate it now, and these pizzas are in their own layer, it means that I only need to like paint a small section of the screen and not the whole screen itself. How you would do that is you basically you put this backface visibility hidden in the mover class in your CSS. So let's go back to the timeline. So basically, this is what our current performance is. If I choose backface visibility hidden, this is the timeline. If you can see here, all of the green, basically no painting involved at all. So I have a lot of extra bandwidth and memory now to be able to do additional things. I would say this is a very smooth frame rate because you're barely hitting no more than half of like your available bandwidth to be able to render each frame. Here's one caveat. So here's the caveat. Here's the trade-off. So painting here, if you look at this, painting here is reduced from 2 milliseconds to about half a millisecond. But the time it takes to script and to render actually increased because we went from 0.5 scripting here to 2 milliseconds scripting, and then we went basically 0.5 milliseconds rendering to almost 3 milliseconds rendering, and that's the trade-off that you have to take, because I think this is my hypothesis. I haven't confirmed this. Uh, the more layers you put on, there's probably more overhead that you need to do and you need to track. If you look at the overall net performance, it's probably a good trade-off. For mobile devices here, this hack can really do a number on mobile devices with low video memory, because basically this hack is forcing the GPU or the video card to actually render those pizzas for us instead of the CPU. If a mobile device has low video memory or it's not a very fast device, performance may actually be poor. The best way to really find out what are the trade-offs is to use these development tools that Google has given us, and also to test the performance on other devices.